Okay, 3.3a, rational exponents. So as a review, what is a radical? A radical is the root of a number. So like, for example, root 25, the cube root of 27, the fourth root of 16. Okay, so how we read this is the square root of 25, the cube root of 27, the fourth root of 16. Okay, consecutively. Okay, so a radical has this symbol here. Now, specifically a cube root, this is a number when multiplied 3 times gives you whatever number is inside this underneath the cube root symbol. Okay, so inverse operation of cubing a number. So say, for example, you have like 3 cubed, which we saw in the previous lesson. Well, in order to reverse this cubed, we would have to cube root it. Okay, and I know we've seen this before. And we can apply that rule to anything. So the nth, like the nth cube, a root where the index is to the variable n. So if we had any number, say we had a number x to the n, we would just nth root it. And this exponent n and the nth root would cancel each other out. Okay, so a lot of us will have an nth root function on our calculator, and we can use that to evaluate any root. So note, if n is an even number, then a has to be greater than 0. Okay, so square root, by the way, a square root, we usually don't write the 2. So square root, a fourth root, a sixth root, and so on. If this number n is even, then the number underneath has to be positive. However, for like a cubed, it can be positive or negative, it doesn't matter. Okay, I'm going to go over why this is. For example, if we have 2 positive numbers, it's going to yield a positive. But if we have 2 negative numbers, it's also going to yield that positive. Okay, so no matter what, if we have 2 of them, it's going to be positive. So in order to root these, it has to be positive underneath. But if we have 3 of them, say we have -2 times -2 times -2, we're going to get 2 2 is 4, 4 4 is 8. We're going to get -8. So we can actually, under like a cube root, we can have a -8, and that's okay. Okay, we can have a negative number or a positive number. Okay, so when we have a number in exponential form, we could have some number with the base of a to the 1 over n. So we're going to have a fraction here. Okay, this is equivalent to the nth right here, nth root of a. So whatever number is in this denominator, it's equivalent to like that root. Okay, so we can go from exponential form to radical form like that. Okay, using this. So example 1, evaluate the following using a calculator to 3 decimal places. So everybody should pick up their calculators and actually try this just to make sure. Okay, so are you able to use the cube root button on your calculator? So the cube root of 20, I personally have a cube on my calculator. Some of you guys may have something that looks like that. And then you have to actually program that you want it the 3rd or like the 4th or the 6th, right? Okay, so when I do the cube root of 20, I get 2.7. Oh, 1 4, 3 decimal places. Okay, so when I do the 4th root of 512, I get 4.75 rounded to 7. Okay, now for C, when we put 100 to the 1/6 in our calculator, like we can do all of these 2 different ways. Okay, for going back, we could have put this 20 to the exponent 1/3. We could have done this 512 to the exponent 1/4. Okay, so for this one, you can either put 100 to the exponent 1/6, or you can put 100, the 6th root of 100. Those are equivalent. I personally like doing the exponents better. And you have to remember for the exponent, you have to bracket the exponent so that it stays together as like 1 divided by 6. So I get 2.154. Okay, this one would be negative 52, the 5th root. So negative 52 to the exponent 1 over 5. And I get negative 2.204. Okay, example 2, write an exponential form, then evaluate. So I'm going to write this as 64 to the 1 over 3. Remember, if you put this into your calculator, group the 1 over 3 together. So you want to bracket it. And I get 4. What this means is 4 times 4 times 4 is going to equal 64. Okay? So if we rewrite this in an exponential form, we want to put this negative 8 in brackets since our root kind of acts like a bracket. Okay? And we can cube root this. Even though it's negative, we can cube root it because cube is an odd number. So I get negative 2. In other words, this means that negative 2 times negative 2 times negative 2 equals that negative 8. Okay, and this is 625 to the 1/4. And I get 5. Okay, again, in other words, 5 times 5 times 5 times 5 will equal 625. Right, because it's quarter rooted. Okay, example 3, write in radical form, then evaluate. So 8 to the 1/3 is equivalent to saying the cubed root of 8. Okay, and if you put that in your calculator, you're going to get the answer of 2. 9 to the 1/2 is the equivalence of saying, just like root 9, you don't have to put the second, like the square root of 9, you just have to put root 9, okay? And then that's equivalent to 3. Okay, so pay attention to the plus minus signs, because these are very, very similar questions here, okay? This 1 cubed is only on the 8, so we're going to bring down this negative sign, and then we're going to take the cube root of 8. So the cube root of 8 here is 2. So again, you bring down the negative sign, and then you write 2. Okay, so these are going to actually be equivalent. Okay, because the cube root of negative 8, which is, if you want me to rewrite this, the cube root like that, okay, this is also negative 2. Just be careful, because if you get something like this at like C, you may think, oh, I can't like square root, or I can't take negative 16 to the 1/2. But the thing is, this 1/2 is only on the 16. It's not on the negative sign. So you bring the negative sign down, and then you root 16. So this we actually can do, and we get negative 4. Okay, whereas this time, the 1/2 is on the negative 16. So that negative 16 is under the root sign. We cannot get that. We get error. So this is undefined. Now we're going to talk about the exponential form to radical form when we're dealing with a fraction or a rational exponent, but the numerator is no longer 1. So in this case, we're just going to call it m over n. Okay, and the way I read this fraction here, like this radical, is the way rational is the way I put it into radical form. So I read this a to the m over n. Okay, so a to the m still exists in radical form. A to the m, right here. Okay, a to the m. Okay, a to the m and then the nth root. So the nth root, that's always from the denominator. Okay, so does order matter? Let's approach this exact same question. So 125 to the 2 over 3. We're going to solve this two different methods. Okay, first method, we're going to solve it doing the exponent first. Okay, so what's 125 to the 2 on your calculators? Okay, I get a really big one, 15,625. And then I'm going to actually do the radical, which is like the 1/3. Or we can even cube root it like this. Okay, what's the cube root of this? Or you can do to the exponent 1/3. Same thing. Okay, I get 25. Okay, so in this situation, we did the exponent first, then the radical. Now, let's do the opposite. Let's do the radical first. So let's do 125 cubed root. So let's apply that denominator there. Okay, 125 cube rooted is 5. Now let's apply the exponent, 25. Okay, so when we're kind of thinking about like BEDMAS, like, oh, which one do I do first in my calculator? Okay, either one, doesn't matter. Okay, example 5, write in radical form first, then evaluate. So negative 27 to the 2 over 3. I can write this as negative 27. Remember, if that's in brackets, it's also under our root sign. Okay, this is going to be raised to the exponent 2 and then cube rooted. Okay, so I'm going to square it first. So what's negative 27 squared? I get 729. Now if I cube root it, I get the answer of 9. So you can do it in any order. I personally like to apply the exponent first. Okay, so this time I get 81 to the negative 5 over 4. We can't deal with a negative exponent, so let's flip the number. Now we have 1 over 81, and this is raised to the 5 over 4. We know that 1 to the 5 over 4 is just 1, so we just leave the numerator, and let's just deal with the denominator. So first, let's do 81 to the exponent 5 and see what we get. I get a huge number. I get 3,486,784,401. Okay, and now let's take that to the 4th root. Okay, 4th root it. I get 1 over 243. You don't have to show this middle step. You just have to show from here, from the start and then the finish, because I understand that a lot of this is going to go through your calculator. Okay, and for C, I'm going to bring down the equal sign, and we're going to deal with 8 to the 2 over 3. So what's 8 to the 2? Again, bring down the equal sign. It's 64. And now what's 64? Cube rooted. Right, because cube root is still there. And I get 4. But bring down the negative sign, so I get 4. Okay, example 6, solve for x. So we're going to assume x is positive. Okay, so recall the exponent law, power of a power. Okay, multiply the exponent so that the exponent on the x is 1. So essentially what we're doing here is, like, if we're trying to solve for x, we need to get rid of the 1/2. The way that we do that is that we think of a number that when you multiply it, the exponent's 1. So I'll tell you the number is like squared. We're going to square both sides here. So 1/2 times 2 just leaves us with x. So x equals 81. Okay, let's see that again with b. X to the 1/2 equals 5. So what number rooted, it's basically what this is saying, gives us 5. So in order to get the 1/2 off algebraically, we have to raise it to some exponent where when they cancel, it cancels to like x to the 1 or just x. Okay, so we get 25. And remember, what we do to the left-hand side, we do to the right-hand side. So if we square one side, we have to square the other side. Okay? C and D are like really, really important skills. So think reciprocal, okay? Reciprocal. So x to the 2 over 5, in order to get 1, we would have to multiply 2 over 5 by 5 over 2. Those would cancel to 1, and we would get x. What we do to the left-hand side, we do to the right-hand side. So now we have 4 to the 5 over 2. Well, what's 4 to the 5? Okay, it's 1024. And then when we root that, we get 32. So x equals 32 in this case. I'll just box my answers. Okay, for D, think reciprocal again. What times 3 over 4 is going to give us 1? 4 over 3. Apply that to both sides. We get x equals 8 to the 4 and then cube root. Okay, 8 to the 4 is 4096. And then we're going to cube root, which is 16. So x equals 16. Okay, example 7, simplify. Express your answers using only positive exponents. Okay, so if we have the same base, what we do is we add the exponents. So 2/3 plus 2/3. Okay, we get x to the 4 over 3. Now it's divided by x to the 1/3. So now what we do is we take the numerator and we subtract the denominator. So I get x to the 3 over 3, or just x to the 1. Okay, and the last one. We have 3y to the 1/4 squared times 2y to the negative 1/3 squared. So in the first bracket, let's apply this squared to each part of this term. So 3 squared is 9, y to the 1/4 squared. What we're doing is we're multiplying 1/4 by 2. So we get y to the 1/2. Okay, 1/4 times 2 is 2 over 4, which is just 1/2. Now we're going to multiply by, well, what's 2 squared? I get 4, y, and then what's negative 1/3 times 2? Negative 2/3. Okay, so normal numbers we treat normally. 9 times 4 is 36. And then we're going to add, because we're multiplying the y and the y, right? So we're going to add 1/2 plus negative 2/3. And I'm doing this with my ABC button on my calculator. I get negative 1/6. So I get 36y to the negative 1/6. We know that this negative 1/6 is on our y. We can bring that into the denominator. So we get 36 over y to the 1/6. We don't have to do anything with this because it's just a variable y. We only have to like 6th root it if it was an actual number.